Hello, algebra students. Well, today we're looking at rational exponents. And this is actually a pretty good one to do on e-learning day because it's really not too hard. And also, you will be continuing to work with radicals in this section, and that will help with the test you have coming up on radicals because we're not going to be done with radicals in section 6.7. We are still working with them. Okay, so here's the really the definition of what a rational exponent is. And we we have here the rational exponent means having a fraction as an exponent. Okay? That's what we mean by rational exponent. So here it is. And we have this fraction here as our exponent. So we know what it means to have a whole number as an exponent, right? For example, x to the second power, a whole number. That means x times x. And it's multiplied this many times, right? The exponent tells you how many times to multiply it. But a fraction, what does that even mean? Well, here's what it means. The numerator of that exponent, in this case that's the 2, that is the power that the variable is raised to. Okay, here it is. And the denominator of the exponent, in this case 3, that is the root, because we're going to apply a radical to that variable as well. So with the fractional exponent, you have both a power and a root, okay, built into that exponent. Again, the numerator is the power, the denominator is the root. Okay, so let's look at some examples. We want to write each expression in radical form. Now note, I have this note that this one is exponential form. And I should also note the bottom one. I'll add that to the notes here. This is radical form. And I want to emphasize those are the same expressions. Okay, this means the one on the top means exactly the same thing. So this is exponential form, and this is radical form, and they are two forms of the exact same expression. So you can always write one of these in both exponential form and in radical form. So in these examples, we're going to change from exponential form to radical form. And remember, all we do is write it as a radical with the denominator being the root of that radical. And then the numerator of our fraction, this is the fraction, right? The numerator of that fraction is the exponent. So here we go. So we have a radical with the root 4, right? Because that's the denominator. I mean index 4. Okay? And 3 is the numerator, so that's the power. And that's it. Okay? The numerator is the power. There it is. The denominator of that fraction is the root. I'm sorry, I keep saying that, the index. Okay. So here's the next one. So this time the index of our radical is 2, because that's the denominator. And since it's 2, we don't have to write it there, right? It's square root. We can just write it without an index at all. And then the 5 is the exponent. That's it. And the last one, our index is 3. That's the denominator of the fraction. And the exponent is 7, since that's the numerator. Okay, so in the next example, we're going to go from radical form to exponential form. So we're going the other direction. The expressions start out in radical form. We're going to write them in exponential form. Okay, so we have our 2x. And in exponential form, we know the numerator of our fraction, our fractional exponent, is whatever the power is. That's the numerator. So that's 7. And the denominator is the index. It's 6. Okay, next one. So what's the index of this is 2, of course, right? And the power this time, we say, well, there's no exponent on that, so that means the power is 1, right? So we have our base to the power of 1, which we don't have to write down. I mean, we don't have to write it in the radical form. It's not written down. But in our exponential form, we write it as the numerator. The power is 1. The index, the denominator, which is the root, is 2. Now notice the 1 and the 2, neither of those numbers is even there in the radical form, but they're understood, right? Because the power on this is 1 and the exponent is 2, even though we usually don't write them when we're writing something in radical form. Because with no index at all, it's just assumed to be 2. Okay, one more. So in exponential form, the numerator will be that power, which is 5. And the denominator is the index, which is 4. Okay. So now we're going to look at some examples of simplifying some of these. Oops. Okay, so we have these, they're in exponential form, and we're going to simplify these, and in the process we will first write them in radical form and then we will simplify them. Once we get them into radical form, we're going to simplify them the same way, or in a similar manner to what we've done before. Okay, but these are the steps over here. Okay, so we first write this in radical form. The index is 3 because that's the denominator, and the power is 2 because that is the numerator of the fraction. Now the order is important here because it's much more convenient to evaluate the root first. But you may be surprised to learn that it really doesn't matter which order you do those in, you will get the same result. It's kind of interesting, it works out that way. So we evaluate the root first, and then we evaluate the power last after writing it in radical form. That's what we should do, because if we do the power first, we're going to get a really big number, right? 125 squared would be a big number. Then we would have to take the third root of that, and that's too much work. You'll get the same answer, but that's not a wise way to do it. Do the root first. Since you get the same answer anyway, you might as well do the root on a smaller number, right? And then you evaluate the power. Okay, so let's do that. We want to take this third root of 125, and for the moment we will ignore the power. So I'm going to sort of draw a circle here. See, that's what we do first, okay? So let's do that. The third root of 125. Well, how do we do that? We just cake it. 125 divide by 5. There it is. We have our group of 3, nothing left over. So it's 5. And then we raise that to the second power. So let's see, I'm going to try to write that back in there. Do that first. Once you get that result, raise it to the second power. And what is that? That's just 25. See, write it like this. Okay, let's look at the next one. So we have 64 to the 4/3 power. So we're going to write it in radical form. So 64, the index is 3 because that's the denominator. The power is 4. And let's see, we evaluate the root first. So we might sort of circle that to show we're doing that first. The third root of 64, you may know this one. We've done that quite a few times, right? But if we take the 64, we're going to get a bunch of 2's here. Okay, we're taking the third root. Our index is 3, so we find groups of 3. So we have 2 of those groups. So 2 times 2 is 4. Nothing left in the radical. So we get 4, and remember, now we raise that to the 4th power. Why the 4th power? Because that's the power in our expression. Okay, and we evaluated the root first, and we got the base of 4, and then we do the power. We raise that to the 4th power. So you just punch that into the calculator. 4 times 4 times 4 times 4, and that's 256. Now we could, of course, do 64 to the 4th power and then take the third root of that. We don't want to do that, right? That's going to be a really, really big number. And so that's not a practical way to do it. Okay, one more. So this is 81 to the 1/2 power. And our steps are now off the screen. But we can remember them. We first write it in radical form. So the denominator is 2, so the index is 2, so we don't even have to write the index. It's square root, right? The power is 1, right? So that's what we would put as our exponent. So we don't have to write it. So that's radical form. Now we simplify that. We do the radical first, and there is no power on the 81, right? It's just 1. So as soon as we do the root, we're finished. And so the square root of 81 is 9, and that's it. So notice that this 1/2 power ended up just being the square root, right? So that's useful to remember, and I'll write that as a note here. Anything to the 1/2 power is just taking the square root. Okay, so that's introduction to um, rational exponents. And we got to work with radicals there, so got a little bit of practice with those. So that's all for today.